So hi students, today we are going to learn about square roots. So we already know about the right angle triangle satisfies the Pythagoras theorem, right? So let me consider right angle triangle ABC, right angle at B, and this is a 3 centimeter and 4 centimeter. We have to find a hypotenuse side, that is opposite to 90 degrees hypotenuse side. So by the Pythagoras theorem, hypotenuse square, that is AC square equal to sum of square of other two sides. Sum of square of other two sides. Other two sides are AB and BC. So square AB square must be added to the BC square. Then the AC square we don't know, that's what you have to find. And AB is a 4 square plus 3 square, right? And AC square is equal to 4 square is a 16 plus 3 square is a 9. So AC square is equal to 25. So here we need a number, right? That number, if you made a square, it should be a 25, right? You need the AC. So if you square the value of a AC, it should be the 25. So that number is called as the square root. Square root of the 25. Clear? So here we need a number for an AC. If we squared that number, we have to obtain the 25. Sure, we know that 5 square is equal to 25. So AC is equal to 5, right? So this process, so this 25, the square root of 25 is called as the 5. Clear? The same way, the square root denoted by the symbol, this symbol. The inside the number you can write any number. Square root of 25, square root of 16, square root of 36. So this symbol is called a square root symbol that we will be using. And here is a 1 square is equal to 1. Therefore, the square root of 1 is equal to 1. That's a representation. 2 square is equal to 4. Then square root of 4 is it's a 2. Square root of 4 is equal to 2. And 3 square is equal to 9. And square root of 9 is equal to 3. You can see the square root of 9 is equal to 3. So it's just nothing that if you take a 9, it should be multiplied by the 3 twice, right? 4 square is equal to 16. Then square root of 16 is equal to 4. And pi square is equal to 25. Square root of 25 is equal to 5. If you see, it is like an square root of 9, we can represent as a pair of the same number, 3 into 3, right? And square root of 16 we can represent as a 4 into 4. Square root of 25 we can represent as square root of 5 into 5. So it's like the same number, this is multiplying inside the square root symbol. Then we can write it the 1. If it is a pair, we can write it as a 1. Then that is the answer. Clear? Examples of 14, square root of 49. If we need square root of 49, we can represent as a square root of 7 into 7. So there is a pair, right? This we can represent as only 7. That is the value of square root of 49. Even we can remember like this. Clear? So here we are going to find the square root through the repeated subtraction. Finding the square root through repeated subtractions. You remember that repeating addition of the odd numbers, we got a square numbers in the previous class. Do you remember 1 plus 3 means the two odd numbers we added, it's a 4. 1 plus 3 plus 5, the 3 number we added, it is a 9, that is a 3 square. So based on the number of odd numbers we added, right? That is the sum of the first n odd numbers is a n square. So we added the two number 1 plus 3, then 2 square is the 4. The same here for the square root, we can have a repeated subtraction from only the odd numbers. You can use the same odd numbers that we have added. Here we are going to subtract. So we can see that 81 minus 1 is equal to 80. We can subtract with the odd numbers until we getting it a 0. So now we subtract 80 minus next odd number is a 3, it is a 77. Now we subtract 77 minus next odd number is a 5, you will be getting a 72. Now the 72 subtract with the next odd number 7, you will be getting a 65. And 65 you subtract with the next odd number, it's a 9, it's a 56. So 56 you subtract with the next odd number which is the 11 and it is a 45. Right? And 45 you just subtract the next odd number to the 11 is 13 and you will be getting a 32. and with the 32 subtract the next odd number of the 13 is a 15, which is a 17. You just repeat until you get a 0. And 17 you subtract the next odd number, so next odd number of 15 is a 17. Here we get a value 0, right? So how many steps we have done? 1 2 3 4 5 6 7 8 9. Then 9 is the value of the square root of 81. This is the one of the method to find the square root of 81. Previously I saw the one method, and here is the another method. Clear? And one more method is finding square root through prime factorization. So square root, consider the square root of 324 here. So I'm going to take in prime factorization for 324. We already know that. So 2 times 162, again 2 times 81. 81 will obtain by 3 times 27, and 27 will obtain by 3 times 9. 9 will obtain by 3 times 3. You can be here only the prime numbers will be using it. That's why this method is called as a prime factorization. We have to use only the prime method, prime numbers. Clear? So 324 can be written as 324 only. We took a prime factor for 324, right? So 324 can be written as 2 into 2 into 3 into 3 into 3 into 3, right? 2 into 2 into 3 into 3 into 3 into 3. So now just pair up. So we will getting a square root. To obtain the square root of 322, just you pair up. Just pair up and write. While obtain the square root, we will be writing only the ones. The pair will be written only the ones. So this pair 2 is written once, and this pair of 3 is written once, and this pair of 3 is written once. If you multiple, you will get an 18. That is the value of square root of 324. Clear? Find a prime factorization method and write in the order. Just pair it up, and each while taking the square root, just each pair will be write only the ones. Then if you solve, then that value is the square root of the given number. So here we go for the next problem. So problem starts here. Find the square root of 100 and 169 by the method of repeated subtractions. We have seen, right? So again we have to do for the number 100. So 100, the first odd number. So repeated subtractions, we have to use only the odd numbers. 100 minus 1 is equal to 99. Still it is not 0. We will take 99 minus next to odd number is a 3. We will be obtaining a 96. And 96 minus next odd number is a 5, which is we will get a 91. And 91 minus next odd number is a 7. So if you subtract, we will get an 84. And 84 must be subtracted to the next odd number 7. Next is a 9. So we will be obtaining a 75. And the 75 we have to subtract the next odd number is 11. 75 minus 11 is a 64. And 64 minus next odd number is a 13. 64 minus 13 is a 51. And a 51 we will be taking minus the next odd number is a 15. And 51 minus 15 is a 36. And this 36 minus next odd number is a 17. It's going little long, right? Okay, let's see. So 36 minus 17 is equal to 19. Next you will get 19 minus next odd number is a 19, which is equal to 0, right? Then the square root of 100 is equal to how many steps? 1 2 3 4 5 6 7 8 9 10. Square root of 100 is 10, right? Obviously we know that 10 square is 100. The square root of 100 is a 10. So what about the next number is a 169. Let me try. I think it will go a little longer. So 169 minus 1 we will get a 168. And 168 minus next odd number is a 3. 168 minus 3 is 165. And 165 minus next is a 5. We will be obtaining a 160. 160 minus 7. Next odd number is a 7. 160 minus 7 is a 153. Which is not 0. So 153 minus next odd number to 7 is a 9. So 153 minus 9 is a 144. And 144 minus next odd number is 11, so which is 144 minus 11 is 133, and 133 minus next to 11 is a 13, so 133 minus 13 is the 120, and 120 minus next odd number to the 13 is a 50. We'll be obtaining 105. So 105 minus next to 15 is a 17. and we will be obtaining 88. I think we will go a little longer also. So 88 minus next to the 17 is a 19. So 88 minus 19 is a 69, right? And 69 minus next to the number 19 is a 21. So 69 minus 21 is a 48. And 48 minus next to the number 21 is a odd number. Remember, only we are using the odd number. 23. We will be getting a 25. Yes, next step we will be getting a number 25 minus next to the 23 is a 25, which is a 0. Little longer, right? But it is easy. Total how many steps are there? That is the square root of 169. We can see that 1 2 3 4 5 6 7 8 9 10 11 12, and this is a 13. So square root of 169 is equal to 13. Clear? So next, find the square roots of the following number by the prime factorization method. So given is 729. So we have to use the prime factorization method to find the square root of 729. Only just we have to find a prime factors and pair it up. That's it. So whether it comes in multiples of 2? No, 3, right? 3 times it will be the 243, right? Again, it will be not in the 2, but it comes in the 3 table. So 3 times 81, right? Next, again, the 81 will not come 2 times. So let me try with 3. 3 table 81, sure, it will come for a 27 times. And 27 is comes in 3 for 9 times. 3 9 times, and 9 will come for 3 times. 3 times 3, right? So 729 can be written as a 3 into 3 into 3 into 3 into 3 into 3, right? So if it is a prime number, we can stop here. Just next, we have to find the square root, right? To find the square root of 729, just you pair the numbers. You can pair, this is one pair and this is another pair and this is another pair. So the pair can be written only once. So 3 into 3 into 3. So 3 3s are 9 and 3s are 27. So square root of 729 is equal to 27. That's it. Right? This is the prime factorization method. So here you go for the next problem. Find the smallest whole number by which it should be multiplied so as to get a perfect square number. So given is actually not a perfect square number. So we have to we have to multiply some smallest number to get a perfect square number. Remember, it should be a smallest number. And also find the square root of the square number. So obtain. So after obtaining the square number, after multiplying the smallest number there, then we have to take a square root of it, right? So 180 is not a perfect square number. We have to check what have to multiple. So I think the prime factorization will help better. So while we are doing the prime factorization method, we can pair up, and which pair is missing, we can multiple to that, right? If any number is missing without any pair, just you multiple with that number, you will be getting, right? Let me solve so it will be easy for you. So 180 I am going to take in a prime factorization method. It will be in the prime number 2 times 90, and 90 is a even number, so it comes 2 times 45, and 45 comes in 3 times, right? So 3 times 15, and 15 comes in 3 times 5. Let me stop in the 5 because 5 is the prime number, right? So 180 can be written as 2 into 2 into 3 into 3 into 5. So now let me pair up. You can see 2 and 2 are one pair, 3 and 3 are pair. So 5 is missing with the pair. So what we have to multiple here? So we have to multiple the 5 on the both sides. So if you multiple 5 with the 80, here also we will obtain the 5. So that 180 into 5, that number is the smallest number. That 5 is the smallest number we have to obtain, and then it will be the perfect square. So 5 has no pair, so multiple by 5. So 180 we will multiple with 5. So the same 5 we can multiple here also. So both the side we have to multiple. Both the equations we have to multiple. 2 into 2 into 3 into 3 into 5 into 5. Right. Now we got perfect square. Right. So what is this? 180 into 5. 180 into 5 is a 900. Right. So 900 is 2 into 2 into 3 into 3 into 5 into 5. So now we obtain 900 is the required perfect square. They said after finding the required perfect square, also find the square root of the square number so obtained. We have to find the square root of the 900. Square root of 900 is just nothing. This paired up we have to write only once. This is the one pair 2 into, this is the one pair 3 into, this is another pair 5. Right? So 2 into 3 is a 6. 6 into 5 is 30 is equal to 30. The square root of 900 is equal to 30. So the required smallest number is the 5. So we will be obtaining a 900. After obtaining, we found a square root. So let me go with one more examples. The same, it is not a perfect square. We have to find the smallest number to multiple here. Then we have to find the square root of the perfect square number. So 768. Let me find using the prime factor. It's an even number. So let me choose 2 times 384, right? Again it comes in 2 times 192. Again it comes in 2 times 96. Again it comes in 2 times 48. Again it present in 2 times 24. Again 2 times, it's a little longer, it goes like a chain. Again it 2 times, it's a 6. Again it 2 times, it's a 3 is the prime number. Let me stop here. So 768 can be represented as little long. 1 2 3 4 5 6 7 8 8 2's. 2 into 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 3. 2 3 4 5 6 7 8 8 are there. So let me check what pairs is missing. These two have a pair. It has a pair. It has a pair. It has a pair. 3 is missing with the pair, so it is not a perfect square. So what we have to multiple here? 3, right? 3 has no pair, so multiple by 3 on both sides. Both sides we have to multiple. So 768 into 3 is equal to 2 into 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 3 into 3. Now it is a perfect square. So what is the value of 768 into 3? 768 into 3 is a 2304. So 2304. The same we will be obtained, right? We no need to multiple in the left hand side because we are going to find a square root value of the 2304. Because the question they asked after finding the value of the perfect square is a 2304, and after finding this we have to take a square root value. So square root of 2304 is equal to, just pair up, this is a 2 into, this pair is 2 into, this pair is 2 into, this pair is 2 into, and this is a 3, right? So 2 into 2 into 2 into 2 into 3. 2 2s are 4, 4 4s are 16, 16 into 3 is 48, right? So square root of 2304 is equal to 48. So this is the answer. So here we go for the next problem. Find the smallest whole number by which it should be divided so as to get a perfect square. Also find the square root of the square number so obtained. So previously it is a multiplication, here it is a division. So sure we are going to, question is not a division, so not a perfect square. Let me choose a 252. So we'll check with the prime factorization which has no pair, then we can divide with it. 252, let me take a prime factorization. I hope you all know the prime factorization well. So no need detailed explanation of the prime factorization. So 2 times 126, again 2 times it's a 63 not in 2 times 2 tables but in the multiples of 3, right? So 3 times 21 and again 21 3 times 7 is a prime, so we can stop there. Clear? So 252 can be written as a 2 into 2 into 3 into 3 into 7. So by the pair you can see 2 and 2 have a pair, 3 and 3 have a pair, but 7 doesn't have a pair. So 7 not have a pair, so divide by 7, right? Now divide by 7 for the both the side, we will obtain the number. 252 divided by 7 is equal to 2 into 2 into 3 into 3 into 7 divided by 7. So the 7 and 7 is 1 times, and 7 table it options for 3 6 36, right? So 36 is equal to 2 into 2 into 3 into 3. So 36 is the square number that required after dividing, right? So next we have to find the square root of the 36. So square root of the 36 is equal to, we have to pair this 2 and 2 and this 3 and 3, right? So it will written once 2 into 3. So square root of 36 is equal to 6, right? Thank you. Find the smallest square number that is divisible by each of the number 4, 9 and 10. So we have to find the smallest square number. That number should be divided by 4, 9 and 10. So for that we have to find the least multiples of this, that is an LCM. We will find an LCM. That LCM is the perfect square. Then that's the number we will divide by the 4, 9 and 10. If it is not a perfect square, we know how to change the number to a perfect square. We will find using prime factorization, we will find which number you have to multiply and we can change like the previous. So first find the LCM of 4, 9 and 10. So for 2 times it is 2, 9 and 5, right? That's it. So everything is a prime number, right? So LCM of 4, 9 and 10 is equal to 2 into 2 into 9 into 5. 2 2s are 4, 4 to 9 36, 36 into 5 is 180. So LCM is 180. Whether 180 is a perfect square? No, right? But after finding the prime factorization, we can know what number we have to multiply to get a smallest square number, right? So 2 times 180 we will be obtaining a 90, and 2 times it's a 45. 45 will be 3 times a 50, and 3 times 5 we already saw in this problem, right? 5 times the 1. So 180 can be written as a 2 into 2 into 3 into 3 into 5, right? So here the 2 and 2 is a pair, 3 is the pair, 5 is not have a pair. So multiple 5 with 180. So 180 into 5 is equal to 2 into 2 into 3 into 3 into 5 into 5. So 1 and 2 into 5 is the 900, right? Now everything is a perfect square, right? 900 is a perfect square. Everything have a pair. So 900 is a perfect square. Then 900 is the least number, the smallest square number, that will divide by 4, 9 and also the 10, right? Therefore required smallest square number, right? So first we will find an LCM. If LCM itself and a square number, it's not a problem. That's the number will divide by here. But most of the case it will be not in the square number. If it is not a square number, use a prime factorization and method and find which pair is lacking, multiple with that pair. So you will be obtaining the number. That number will be the smallest square number. Thank you, children.